All right, so we're back with an actual kind of problem that has units we need to label. So here it says cell phone subscribers. The figure shows the total number of cellular phone subscribers in the US from 2000 to 2008. Draw a line segment to the graph at point P and estimate its slope. What are the units of measure for the slope of the tangent line? And then write a sentence of interpretation for the slope of the graph at point P, and then calculate and interpret the percentage rate of change at point P. So let's first draw a slope or a tangent line here to find that slope. And I'm going to call that good. And so we'll need to find what at point P is. So what is that? Maybe, how about we write that as 4.8 comma 60 is probably 62 and maybe 62. All right, so now let's do another point. Let's pick 3 and maybe call that one. Again, this is so arbitrary. 3 comma, that's 52, 50, maybe 54. We'll call it 54. Okay, so our slope, we say, is roughly 62 minus 54 over 48 minus 4.8 minus 3.0. And so if we do that, we have 62 minus 54 divided by 4.8 minus 3. Okay, so it says that's 4.44. Okay, that's close, I guess. Now, what are the units of measure for the slope of the tangent line? Well, our slope is going to be 100,000 subscribers per year. So it's going to be 4.4 100,000 subscribers per year. Okay. And write a sentence. Okay, so let's see. So this is in 2005. So in 2005, the total number of cell subscribers was increasing uh, by 4.4 100,000 per year. So that's kind of that instantaneous increase there. Okay. Now calculate and interpret the percent rate. Okay, well that's going to be percent change is what I'm going to label as to keep some time down. And so that's going to be our 4.44, our f, this because this, remember, this is really your f prime of x now, or whatever we're using for our units, but f prime of x. And that's going to be divided by the original, which we said was 62. And so then what else is there? Oh, then times 100%. So we have 4.44 divided by 62 times 100, and that's going to be roughly 7.16%. And so 7.16%, and that's per year. Okay. Now, what does that mean? Now we're going to say, well, now we have to write all that again, but we don't have room. And I'm pretty sure I don't have room on the next page, so we'll write it on the page previously. Now I have to remember what I said or what it says. It was, I think, in 2005, the total number of cell subscribers was increasing by about, because that was close. What was it? 7.16, sorry. Let's erase that. 7.16% per year. Okay. All right, so that's what we would say for the interpretation of what this 7.16% per year meant. Okay. All right, so again, depending on if you drew your line correctly and did all the getting your numbers as close as possible, is that really 54? Is that really 62, or is it maybe 63? It's all pretty arbitrary on that part. So if you're in the right ballpark and you have numbers showing and your labeled points correct, as far as that goes, that's going to be about as good as we can get on these, I think. All right, so this one says the growth of a pea seedling as a function of temperature can be modeled by two quadratic functions. So, we have quadratic here, and this one probably is coming down and doing something like this. So we're drawing tangent lines at A, B, and C and estimating their slopes. Write a sentence of interpretation for the slope of the graph at point C and calculate the percent of rate change at point C. All right, so let's go ahead and draw those tangent lines. So that's pretty close. We'll probably mess it up if we go anywhere. Yeah, that's it's below. It's through the point still, so it looks good. Now let's do another one. Let's go up this way this time. Now is that changing there? That might be the inflection point. So if that's the inflection point, let's move that up there. And that's probably as good as we're going to get for the inflection point there. And this one, I don't know, it might not be an inflection point. I don't know. It's hard to say. It might just be a tangent to it. Again, it's hard to tell what these are in the book as far as your graphs. So we'll call it actually a tangent. It's not an inflection point. Again, it won't let me get any closer than that. So we'll say that's right through the point of tangency and not actually through the graph. And we'll do one more. We'll do the B, and it's not going to draw. All right, so that's pretty close to the tangent point. We'll call it good anyway. All right, and so now what we're supposed to do is estimate their slopes. Well, since everything is through C, I'm just going to let's just do the estimate the slope for C, because as you can see, we're not exactly sure if we're really close to these numbers. So estimating something that we're not even sure about, it's kind of a shot in the dark. So let's just do point C. And so let's choose this point as well. And so here, that looks to be, we might just say that's 32.27. We'll just call it that, and that way we don't have to worry about, is it close or not. We'll say it's 32 comma 27, and then we have our in parentheses didn't show up. And then our next one may be, we're gonna have to lengthen that line a little bit. Is that close? I would say 35. Ooh, and then what are we gonna call that? So, I don't know. Let's make some markings here. So if that is maybe halfway, then that's half of the half. Then that's going to be half of that's. Well, where are they going here? And then that's going to be right between them. So this is probably like that. So that looks like, so it's going to be 1, 2, 3, 4, 5, 6, 7. So it's going to be 5/8. So maybe maybe that's about 14. Let's call it 14, just because that's going to make it easier. We won't do anything different. 35, 14. That's what we'll say. Again, these are very, very rough estimates. So we'll have change in y, so 27 minus 14 over well, which one's higher? That one's higher. Yeah, okay. Then 32 minus 35. So we have our negative slope, which is good. So 27 minus 14 divided by 32 minus 35, and we get negative 4 1/3. Okay. Now, so that's our slope, and again, I'm not going to do A and B. We're just going to say we're not doing those. We're not even worried about them because it's so much guessing. We're just worried about C, and so we're going to write an interpretation for that slope, and it looks like it's going down. What is the units here? It's millimeters per day. And so that is per, then we have degree C. So millimeters per day per degree C. So that's how many millimeters it's growing per day per degree Celsius is really what it's looking at. And so what we can say then is for our part C, if we have to interpret that, we can say at 32 degrees C, because that's what part C is. The growth of the pea seedling is decreasing because we have a negative, and by 4 1/3 millimeter per day per degree C. Okay. And so that would be basically our part B. Part C, calculate the percentage rate of change at that. So percent change is going to be equal to our f of x. So remember, this is our f prime of x. And so that's going to be negative 4 1/3 divided by our 27. And so then we have to multiply by 100%. And so now if we take that divided by 27 times 100, we get about roughly approximately 16.05% per degree C, because again, the millimeters per day are canceling, and then we have just the per C left, and we have that percent added in because of the percent here. Okay. And so again, now we have that 32 degrees C. The growth of the pea seedling is decreasing by 16.05% per degree C, because we don't have room for that. So this is by, and then this is part A, and then, or B rather, and part C says 16.05% per degree C. Okay, so that would be what that is. All right, so that's all I have for this section.